Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Systems at the College of DuPage in Glen Ellen, Illinois. And this is a look into Chapter 13 of the Gaddis C++ textbook, Introduction to Classes. So we'll be taking a look at moving on from our idea of structures and moving on an idea and adding to that and adding and introducing the idea of what a class is. And so before we look at the idea of what a class is, we kind of have to take a look at the paradigm shift. We're not going to take a huge look, but it is a big shift from the way of thinking of how to program, because if you have never done object-oriented programming before and you've been working through this course, then we move away from just having pure functions doing all the work, and now the functions actually do work on specific pieces of data, and you'll see. So it's very much like everything you've been doing. It's just now we're going to combine everything into a whole new topic here. So again, you're used to the idea of procedural programming at this point because we've never done anything object-oriented. We've done everything in either the main function, and then when we hit Chapter 6, we started moving over and creating separate functions to do a lot of the work for us. But since we haven't really been doing too many complicated programs just yet, maybe your instinct on using functions to do a lot of the work just isn't there yet, but we will fix that, because you can't do anything without the idea of functions when you're dealing with object-oriented programming. So we take the idea of the structure and we start advancing it. It's an abstract data type. That's what a class is going to be here, and it's based on data and the functions that operate on it. So it's very similar to what we did in the hour-long previous lecture for structs, but this time around, again, instead of just using just the pure data, now we're going to also advance the functionality of it all. So, why do we do all of these kind of things? Why do we care? Things get blown out pretty quickly when you have to have a large system, and because the idea of object-oriented programming came about because a lot of the times, like, how are we going to maintain for objects? How are we going to maintain a ton of data for specific objects? Because that's how we think, right? We don't think of this as, we don't think of the world as an array of different attributes that all somehow apply to different characters or different creatures or different things in the world. We think of them as an object, Brad, with a height and a weight and, all of the other aspects. And a tree, what type of tree? An animal, what type of animal? This, that, whatever. That's how we think, for most of us think anyway. And so we're trying to create programming constructs that more similarly, accurately, look into the way we think. So what would happen? Say, trust me, I've been here. Object-oriented programming wasn't a thing that was being taught to me growing up when I was an undergrad. So I came back to it 10 years later, and it just, it was an exploded thing. Everyone was using this idea of object-oriented programming, so I had to get myself back on board. So if I have to change a data structure, especially thinking to not using object-oriented programming, I have to do a lot of work under the hood. If somewhere along the line someone says, "Oh, Brad, for this game character, add some attribute," it is going to be a ton of work. So we have to think this all out ahead of time and make a simpler game, or we have to spend more time on the back end when things are, when people decide to make changes to any of the code bases. And so since basically it ends up being hack after hack after hack, the later you move into a project, you could understand if you're hacking and hacking just to get something done on time and under budget, or hopefully that way, things are going to become more difficult to understand as you're looking through code, to maintain, because if you hacked it and now you're like a house of cards kind of thing, like all it takes is one mistake and then you're like, oh, I got to fix so many more things, and it just keeps exploding on you. And it's in that same, it's easy to break. You're like, it just takes forever to add one more concept to whatever it is you already have going on. So a class is like a struct. A class is like 99% of what a struct is, and struct is 99% of what a class is. So we can allow bundling of related variables, but variables and functions in the class can have different properties than in a struct. Yeah, you'll see. But again, that might have been the old C definition. I'm not a C expert by any means. I'm a C++ guy. So I don't know if that statement 100% holds water. But an object, so there's a difference here between a class and an object. We are going to set up a class. So I'm going to set a class circle when we get going here. Make this a tiny bit bigger. And so a class is I think we can show it here. A class is a blueprint, like for a house. This is, so basically a perfect ideal house would be set up using a blueprint, using a floor plan for everything. And then when you go to actually create these objects out in the real world, you take the blueprint and you take materials and you start stamping them out. I live in a house. I used to live in a condo where everything looked the same. Basically it is. Everybody looks the same. Everybody starts out. There might be different data sitting inside of here, different people living here and so forth and so on. And the states of, if there's a leak in one house or something, or if a shower doesn't work, it's in one house and one house only. It's not like in the real world. It's not like, this doesn't happen in the real world where somebody gets a flooded basement and every house in the entire world gets the same flooded basement. It just doesn't work that way. And the same will work with computer programming, of course, between two separate variables, two separate objects of the same class. So say we've already set up the attributes. So coming back to last time, like how would I want to go about this? I would love to have a double for my X position, a double for my Y position, for the center of my circle in space, and then a double for my radius. So in a way, this still works out. So if I just, this, looking back to the last lecture, this is minus the word struct, and I include the word class here. Right now, this would be allowed, but there's things that would prevent me from actually using this, and so that's why we have a whole chapter on this, because there's more to do. And so we especially have to add functionality. Wouldn't I like a way to set this thing up so that I could print out all of this of a circle without having to do a ton of work? If I do the work up front and I use it as part of the class, then you'll see that I write it once and everyone can use it forevermore. Just like all the objects that we've been using, cout, cin, and files and so forth, that we've been, in string even, that we've been using for the entire course. Okay, so one thing we're going to discuss here, and this is one of the big tenets of object-oriented programming. What are the big tenets? There's data hiding, there's encapsulation, there is inheritance, and there's polymorphism. There might be more, but they're not the hugely important reasons for being. And so when we were using the struct system in the last lecture, anybody could pretty much go into that structure at any time and change whatever they wanted to change. And so, if you're a Python person, that's not a big deal. We learned to live with that, which is true. But in a C++ world, when we're setting these kind of things up, we go, well, certain aspects, certain fields, certain functions should be publicly accessible. Who's ever going to use my class for circle can go ahead and set an X value or a Y value or print or do other things, figure out maybe an area function or something like that. But at the end of the day, maybe some of those things don't apply. So maybe not for a circle class, but if you have some kind of student record class, maybe I can access their name, but maybe I can't access their address, or maybe I can't access a phone number, or I can't access their grade records, or things like that. So even though the data might be sitting there somewhere, like on the computer, I would not have public access to that information because because I'm not allowed that information. Someone else might have public access, but that would be a different class structure that allows me to dig in and find that information. So that's, there's data hiding and public interface. It's a big deal here. Encapsulating and giving an API is what we call it, and a programming interface. So the people that are using my code have a very nice, easy way of going about using it. Try not to make it complicated, because under the hood is where it's complicated. That's my job to make it work. It's your job to not even really think and worry about it and just get your job done. And so that's where the idea of this comes from. So I've already started this here. But one big thing here, structures, we kind of put it all in one file. But when it comes to classes, now we start complicating things quite a bit here when it comes to how many files are going to be in my program. So now I'm going to start offshoring this thing. I'm going to move this thing over, and I'm going to create a .h file, not a .cpp file, a .h file. This is our first time doing this, called circle. So there's two separate types of files in C++. There's a .h file, and then you're very familiar with the CPP file. So a CPP file is generally where your code, or your physical actual code goes. And so that's why we've been using source.cpp or main.cpp or just something.cpp for basically the entire term up until now. And then afterwards here now we have these .h files, and so we're going to see here that the circle class, this is what we call a header. Everything that goes inside of the class declaration itself is going to be called the header, and then all the implementation of everything we talk about in here is going to go in another file called circle.cpp, and that's where the implementation, the code, is going to go. So it's we break up things. Every class consists of two separate files. The .h file, which is going to look a little bit more complicated than this, but is not going to have any real actual physical code in it, and then the CPP file, which will have actual physical code in it. So you got to make sure you have all these things, all these files in your project, because without it, even though the files might exist on your hard drive and all those kind of things, without putting it as part of your project, the compiler will not know to use them and tie them into the final product. So they have class rectangle here. I have class circle. Let me go ahead and let me just go through and just pretty it up the way they have it here. I'm going to say the Gaddis kind of does everything but opposite of the best practices I've been ever taught. Nothing against Gaddis, just something like that. So if I have an X, a Y, and a radius, that would be private data. And so we'll see here, and the general rule is private data does not get public access. I have to supply functionality to allow that to happen, and that's what all of this is about here. And so if I wanted to, I could set up a void function called setX, and then I would pass along an X value. And then if I wanted to get the value, it would return back a double. And I would call it get. I usually put the gets in front of the sets. I know it's pedantic, but that's just me, right? And so there's two ways to get the information. The data itself is going to be private, but I have a method to get it, and I have a method to set it if I want to change it. And again, what's nice about this is if I ever change my mind about this, I can get rid of the function. But if I made the data public, anybody could go in at any time and change things. We'll show again in the future why there's more than just that reasoning for why we do this. So then just to triple up on everything, do the same for Y, and then do the same for get radius, and same for set radius. And anything else we want to do? How about like a double for get circumference, and a double for get area. Those are common things, right? Okay, so there's a lot of functions, but you can kind of compare. Oh, and then, yeah, let me just to finalize everything and be nice about it, let me put in consts for all the get functions. Put the little word get here. Again, we'll discuss all these details, but let me just get us up to speed here so we are equivalent, but slightly different here. We're using a different case than what they have here in the book. So don't mind the green squigglies. The green squigglies just tell us that the function has not been defined yet. And that is the difference between declared and defined. Declared means, trust me, you'll find it somewhere, and then defined means, oh, and no longer a trust. Here it is. Here is the actual function that we're dealing with. Okay, so public versus private access to these functions and the data. So again, public can be accessed by anything outside of the class itself. So anyone who sets up an object, anybody using this can touch any of the public functionality or variables. In this case, it's just functionality, and then that indirectly gets me into using the data. So it all comes together once you kind of see it in practice here. And so private can only be accessed by the members of the class because we're trying to maintain that data privately. And so, and it's not sometimes it's not even for just security reasons. Sometimes there's just a lot of complicated things going on, and if I change one aspect of an object, it changes other things. Like a video game object, if I change my speed, I'm changing a velocity of how this object is moving around in space. So by moving or changing one attribute, I'm changing others as well. So I have to make sure there's functionality in there to basically, if something is occurring, to change more than just one thing. And so that's another reason why we're doing a lot of this stuff here. So public versus private. We'll see the word protected in chapter 15 when it comes to inheritance and polymorphism and all that kind of stuff. But those are the big basic three, they call them access specifiers when it comes to security and allowing use of the functions and the variables. Oops. So private and public, and I put the public stuff first, and that's just from experience over many years of doing this, that the private information you don't necessarily care about unless you need to dig deeper. And you only need to dig deeper 1 out of 20 or 30 times you go into the code, because a lot of times you just care about what's my public interface, what do I use to get my job done, and then when things start breaking on you, then you kind of need to dig a little deeper to see, is the code actually broken in the circle, or what is going on in the circle class at all, so I could understand, so I can start to piece together what's actually wrong with my program. And so over time, it probably wouldn't be in the circle class, but at least it would help me elucidate the problem. Okay, so we can list them in any order, but I go public, then protected, then private. You can have them all over the place, but if you don't put anything in there, it's default private. And that comes back to what is the only true difference between a struct and a class. And the only true difference, honest to goodness, is that a struct has public access by default and a class has private access by default. That is it. Honest to goodness, that is it. Okay, so now we have these idea of consts. All of the get functions have them, and I did not put them with the set function. You know what const means. And so what the const means at the end of a function basically says that when I go to use this function, I'm not going to modify any of the data in the class, in the object, while in the process of using this function. Because you can understand, I'm just trying to get information, so I'm just going to pass a copy of the x value, or the y value, or the radius, or the circumference, or the area. I'm not modifying anything under the hood. That would be weird, right? Give me the x value and it just changes. No, that doesn't work. So we can put the word const here to indicate that, and it helps us on the programming end. And in C++, it helps us in other regards as well when it comes to the way the standard template library is set up with all the constness, because they have const functions and const this and const that as well. And sometimes if you don't follow along with this, you do have issues getting things working, again, with the standard template library. So it wouldn't, if you didn't do this, it wouldn't be 100% wrong. Got to be, since there's no const keyword in Python or anything like that, but just be aware that for any function that doesn't modify the object, you should throw a const in there. Okay, so now we have to define them. And so, so now there's one easy way to do this. Let me show you the hard way to do this. Oops, where did it go? I can't get this thing up. It's all, oh goodness, there we go. So let's see. So what you can do this is pretty cool here. I don't normally do this kind of stuff because I only have 1080p to work with here with you guys anyway. Is that what I can do is set up a second file called circle.cpp. New item, circle.cpp. And then what you can do is you click over here and drag, and you can actually have both files open at the same time. That's what we're going to want. Oh, don't mind this pragma once. We'll talk about that at a later time. So now notice I have 2 files for circle and 1 for source. So I have 3 files working that will be working together to make this thing go. So, but the first item of business is to turn all these things from being green, right? So what I do over here in circle.cpp, the first thing I need to do is say, hey, because every file is individually compiled, I need to take a look in what's in circle.h. And you need that, of course, because I need to access everything that makes a circle a circle. Okay, so coming back to the talk here, let me put this guy here. This is the setup. This is how you do this over and over and over again, the prototype for a class member function. So if I say, okay, I'm going to use the getX function, let me just copy this over. We'll do it the hard way one time, and then we'll do it the easy way for all the other ones. So I say, okay, the return type is always the same. This is always the same. That's always the same. Don't mind the red right here. But what we need to do is add one thing to this, and I say circle : : just like when I do std : : and things like that. Like this is saying, oops, I just have to spell circle, right? What this is saying is, using this circle.h as a template, I am defining what the getX function means for being a circle. And so, and you notice it didn't turn, it's still green over here until I click here. And now the compiler, the system here, the IDE, agrees that there's a definition of the getX function already here, which is very nice. But now I have to go ahead and fill in the gaps. And what have they got? They've got themselves with equals W. They have a set function. We have a get function. And of course, we want to return just like we would just basically play with the x attribute of the circle if it was a struct, but it's a function that returns a double, so I'm just going to return the x value. That's all I'm going to do. Because for a specific circle that has an x, a y, and a radius, I'm just asking you, can you tell me what the x value is for that circle? And there's no reason for you not to oblige. And you go, sure, it's 4, or it's 6.2, or whatever it happens to be. So then, to finish up the deal here, I could have my void function, circle, colon, set x. And then this is, I'm going to be passing in a double value of the new x value. And just remember about the whole way that, okay, see how it fixed up over here? And so I'll just say little x equals big X. So this is where you got to be careful, because little x is a variable, large X is a completely separate variable because of the case sensitivity. But that's all I'm going to do here is just blindly set. And if you wanted to, this is another, like if the data comes in poor, I could do something about it. Like if it comes in negative, am I allowed to have a negative x value? Am I allowed to have a negative radius? I don't have answers to that right now, but maybe you do. But this is your opportunity when someone tries to set something for you to go, nope, that doesn't work. That doesn't apply to what I'm trying to do. And you can do something about it. You could throw an exception. You could silently fail. You could do whatever you need to do. But when it comes down to it here, we've pretty much set up the get and the set functions for just the x. And you can notice now there's 6 other functions. And say, back in my day, I didn't have this cool little trick because I wasn't using Visual Studio. I was working in a Vim environment, an old Vim environment. So I had to write all this out myself. I just lied to myself and called it, I was cathartic, because you're slowing yourself down so you could think about what you're doing. No, you're just wasting time, because can't someone else write this code for me? So how I go about doing this is I click and highlight all the other functions. I right click, I do quick actions and refactorings, and I do create declaration / definition, and there we go. And so it fills in all these other functions for us. I had to at least show you how to do it manually, right? So, but now the only difference here is I have to go back and clean everything up, because it really doesn't truly know how to set and how to get. Notice the set function is blank, and the return and the get functions are just returning zeros. So it did the hard work for me. Now I just got to go back and do all the other tedious stuff. So let's see, get, set, get y, return y. Oops, sorry. Set y, little y equals big Y. Get radius, return radius. Set radius. Oh, I just got to fix this up. Forgot to do that. That wouldn't make no sense. What's x mean? I mean, you would figure it out. It's not that complicated, but even so. And then radius equals radius. And notice there's it's a lot of code for one-liners, right? You're like, what is the point of this? Again, the security. There's so many, security, inheritance, polymorphisms. There's so many reasons to spend the time and effort and make this more complicated. So circumference is just pi diameter, right? Like something like that. So 2 times radius. Just have to spell radius times. There's no thing for pi in here. 3.14159265335. And oops, lowercase radius. And if I wanted to, I could go ahead and find more. I probably should find more, because this is only good. How many decimal points did I go to? 10. And so, yep, notice here, I mouse over the thing. Yep, I've still got quite a few I could go with. So I better look that up, and I'm going to do that right now, just so that I can say I'm at least as precise as I can get. So why in the year 2020 is pi not part of the language? I do not know. 3.145926535, that's I already did. So I can add these numbers. There we go. And let's see, what is that? Does that get me any further? There we go. Let's see, 3116. 3116. So even doing this, whatever, this is the closest it can get me, because again, this is an irrational number in base 10. It's absolutely irrational in binary. So this is the best by putting in, so you could even probably cut this down a little bit, but there's no reason to worry. So if you wanted to, you could set this up, at least in our class or something like that. I could say is a private or public even. You could just set, a const double pi equals, something like that. Consts are okay like that, so I can use pi in that regard. And so get area is 2 pi times radius. no, pi r squared. Wait, oh my goodness, pi times radius times radius. Pi r squared, pi r round, yes, whatever. Okay, so that is how, oh, and I want to make sure I do this right, 2.0, make sure I'm multiplying by a double and not by an int. So, okay, so there we go. So that should handle those functions, right? I mean, I'm basically returning back the circumference. I'm returning back the area. One thing you notice here, I'm not creating different data members for this. You'll see this in the slides, that if I can calculate it, just go ahead and calculate it on the fly when someone's asking for it. Like, again, coming back to video games, sometimes you cache the data, you know, especially we're trying to speed things up and there's a lot of really complicated calculations that have to go on in video games sometimes. But for something like this, a couple multiplications isn't going to kill anybody, so there's no reason to store this data for every object that's of type circle. There just is no reason for that. Okay, so now I can drag everything back, and now we can go ahead and take a look at all the other details. So once you've written your code, and we haven't tested it yet, but once you've written the actual source for the circle, we don't really need to look at it anymore. Now, since it's written, we can trust it, quote unquote, and we can actually go ahead and only use the .h, the header file, and we can kind of just let the code fall away, which is great because then there's less for us to worry about, right? That's a big part of what we want to do as programmers, get our job done, be lazy, and not have to think about the things that have to be done. And lazy is, we do that tongue-in-cheek. There's a lot to remember and a lot to do, but just to say that, exactly that. So we have two different types of functions. We've already kind of discussed this. The accessor functions are functions that don't modify anything. So those are the const functions. And things that do change things, like mutators. I don't know, did we still use that term truly? I heard that way back when I was going through college, but I've only heard it in college. So mutator, anything that changes. So basically any of the set functions or any function that modifies anything in any way. So that was our setup. Right? So that is the basic outline, at least getting started, like of just figuring out the basic behaviors and functionality of what a class and what its objects are going to do. And now it's up to us to go ahead and start using it, defining instance of the class. So we go from class to object. So we go from blueprint to stamped out object. So I can go into source.cpp now to start working this out. So you're like, well, okay, you said this thing is in my project, so I'll say circle C. And you're like, no, it doesn't work out. And it goes, circle is undefined. And so even though it's in my project, it's not linked anyhow by any means by any include file. IOStream doesn't get me there or anything else because I don't only have the one include file. So I'll need to include circle.h, and now here's the big difference, it's under quotation marks. The angle brackets are set aside for libraries that are part of the standard language, and anything else that is programmer defined gets put into quotation marks so that it's basically not looking wherever it needs to look in the projects inside of Visual Studio itself, but it's looking inside of my project for that specific .h file. And so once I have that, this will no longer turn dark blue. This is the lighter blue. That's why string turns that same color. And that's because string is not a base data type. Int, float, bool, those are the atoms. Those are the atomic elements of computer programming. But anything that's larger, a struct or a class, turns this cyan, this lighter green, because it uses those atomic elements, as we have three doubles sitting inside of the circle, but we're not doing anything directly, you know, they're not atomic at that level. It's like more of a molecule, some kind of compound. Okay, so once I have this circle C, now I can do it just like I was doing it before, but I can't say C.x. That would have happened last time with the structure. Say C.x equals 22.0. This will not work, and you'll get this. Oh my goodness, right? Blah, blah, blah. This member, circle, : x, is inaccessible. You will see this very, very much anytime you're trying to access something publicly or in a context you're not allowed. Because remember, that's a private piece of data sitting under the hood, and I can't access that directly. My only means to get there is to set up and say I'm going to use the set x function. And say, okay, I'm going to pass 22 into C to this function, and then the circle will do the work to actually make the X attribute the 22. So it's one extra level of abstraction, but it's doing the same work. It's setting 22 to that value. Or hold on, let me put a breakpoint. Let me put a breakpoint here. So let's see. set up the circle. The circle has pi as an attribute. It has all this other stuff uninitialized. And so now when I go into here, now you can see it goes into this function. D coming in is 22. The lowercase x is still garbage until it gets to there. Now lowercase x is 22. And so now my circle has the correct attributes. It has pi, it has x, it has y, it has radius, but the x has been set because that's the only thing that I've explicitly gone ahead and set up. And so I can go ahead and print, like I said, this, if I'm going to return a double from this whole thing returns, or this returns a nothing, it's a void. But if I go ahead and set up and say, okay, set up and give me the x position, because this is where we're going with things here, is c.getx. And then give me a comma, and then I say, okay, give me a get y, and then give me a closing curly brace or closing brace with radius, and then single quotes and then double quotes. Here, let me just break this up onto two separate lines since I'm running out of space there. Say radius, and then I can see c.get radius, and then I can have an end line. Or should I keep on going? Because I have all these other attributes now. I'll say, okay, maybe I'll add another space, and I'll say area, and then just close this off. Say formatting is never looks nice. C.get area, and then add another space and circumference. Hey, I can spell something more correct once in a while. And then just to finish things off on one more line, print out c.get circumference. And then now the end line. Whew. Okay, so let's set some of these variables. Let's make them a little nicer. I'll say 0 for the, 0.0 for the x value. Oops. Yeah, I do want to stop debugging. No, I don't. Okay, set y. Oops. It undid everything I did. Let's see, 0 to c.radius, set radius, is equal to 3. We'll just say 3. And let's see what happens. Let's print out. And so we'll go in. I set the x. There it goes, setting the x. I go in. I'm setting the y value. I go in. I'm setting the radius. And now this object is set up with all of the variables set up correctly. X is 0, y is 2, radius is 3. There's pi again. And now I'm ready for all these different print statements. And what have I got here? 0 to radius 3, area, we'll have to go with, let's say, pi r squared, 9 times pi, seems about right. And then, 2 pi times, or 2 radius times pi, 6 times, yeah, so it looks like, we would have to do more math to be 100% certain, but I think we're 99.9% certain that everything is coming out like I expect it to for this specific thing. So we've used all the functions. We've used all the gets and all the sets. Right? That's basically what we've done. And so their rectangle class works exactly the same. So you can use the set functions and the get functions however you see fit. And in their case, the rectangles are returning doubles just like ours are, or I think they're using floats. I don't know what they're using. But you can see we have doubles and we have voids for these functions. So you got to make sure you use the correct stuff. So here's their, this is what exactly they're doing, exactly what we're doing. Width equals W, length equals L, return. And then the get area, just return width times length, and so forth and so on. So sometimes I'll see students put parameters in for these kind of functions, but you don't need to, because when you set up an object, the data is sitting under the hood for that specific object. All the data that makes this thing a circle is sitting there. So I don't have to supply any extra information in order to get the circumference or get the area, because that information is already a given. And that's why inside of that CPP file here, for us, that's why it's weird that you didn't define any variables here, 2.0 times radius times pi, but they exist because they're part of the circle class. So that takes a little getting used to sometimes, that and when we get to inheritance, sometimes it can be even worse, because the variable name that you're trying to use won't even be in the same class. It might even be you might even inherited it from something else. You might have to go 2 or 3 levels up to even find the variable, but you can still access it because it's part of what you are. And so this gets tricky, right? I'm just coming back one more time here, saying that this radius, even though you don't see it defined anywhere here, because it's part of circle and it's defined right here, I can go ahead and use it. And so again, coming back to this idea of stale data, why are we just returning like the calculated values? Again, a couple reasons. I already told you the one earlier, but the second one here, when it comes to stale data, is that how do I know I'm giving the user correct information? If I ask for a circumference, things are changing, circle is changing sizes and moving around in space and rotating or who knows what else. How do I know that everything's been updated and at any given point in time? Because if I said get me my circumference and it gave me a value, how about a minute later? Is that circumference still the same value? So basically, instead of just getting a value and just trusting that it's going to stay the same, sometimes you have to go out and every time you need it, you just ask for it so that it's not stale, because things can change, things can be modified. So it's to avoid something like this, calculate the value exactly whenever you need it rather than store it in a variable and return that. And it also adds complexity. If I have to maintain that, not saying sometimes I have to do this, but not in this course for sure, but when I do have to do that, there's a lot more upkeep to make sure that all the variables, when I change all of these things under the hood, that everything is available to the user correctly when they ask me to return whatever it is they need from me. Oh my goodness, we're getting right into talking about setting up pointers. If we can set up pointers to ints and floats and structures, we can set up pointers to circle objects or any type of classes as well. So there's nothing overly complex about it if you understand the whole idea of a pointer. Circle pointer D equals address of C. So now I have two different ways to access the circle. Remember, pointers have to point to real memory addresses of hard concrete data. So address of C, D equals, right? And so there's two ways to access the data, as you know from structs. One way is to go through C directly, and the other way is to go indirectly through D. And so remember, just like struct idea, if I have to dereference and then access something, I have to use star D, and I got to use the parentheses around it because of the order of operations. But then you can see I have access as if I have everything else. But that's not how things go. We use the arrow operator, and it gets me to the same place. So in this case, I can set the radius to 4.0, and you can see again, it will change everything in my program. Because it'll set the radius to 3. So circle C, there we go. Oops, not there we go. There's my radius set to 3. But using these two lines of code, setting up an alias and setting up an alternate plan here to get there, C, even though it's set up as D, notice it's now a 4. And the same goes for D. D is now pointing to that same thing. And you can tell because look at that memory location. D58 is how it completes. This thing is pointing at, oops, it's not even going to show it to me. Ah, shoot. I wish it would show me the memory location. But again, this is where the data is being stored, and this is just a pointer. At the end of the day, this is just 4 bytes of storage that tells me where a circle object is in memory. And so printing this thing out, there we go. So even though I've changed it in C to 3, I've also changed it to C by using D indirectly, changing the radius to 4, changing all the math behind the scenes. Okay, so, and we can always, so I say the other way to do things here is to a new one up. So that's a little different here, right? So this changes things a bit. So if I say, give me a new circle for D, and then I set the radius, and now coming back, so now C and D will be completely separate circles. C is generated at compile time, or a space is set aside at compile time. D is generated at runtime, and dynamically the operating system will give me the memory for that 24 bytes of storage when I ask for it when I hit line 11. And so since they are two separate things now, the 3.0 will stay, as you could probably expect. And so now the 4 doesn't blow it out, so now it's back to how it was prior. And the D variable here, let me just go ahead, is also, is not initialized completely. Only the radius has been initialized. Okay, so that's, so I say like, how hard is pointers and dynamic memory? It's the hardest thing ever, but sometimes you just gloss it over. Okay, so a few more things to talk about, and then we're ready to move on. So why have private members? I already kind of discussed this. We have data protection. There's nothing saying I have to allow you access to any of this data. So if I went ahead and commented out the get function, maybe you could set, or something like that, right? Or just in general, the set and the get. You can't touch X. Once you set this object up, you can't touch it. And so right now, there's no idea, there's no way to initialize a circle just yet, as much as we like to think there is. But sometimes, again, coming back, some of the data sitting under the hood is supposed to be private. Just because there's data sitting on a computer it's not yours to gather, right? So hacking, trying to figure out people's bank accounts and email addresses and whatnots, right? So we allow public access to the things we want, and then we basically just privatize or eliminate access to the things we don't. So again, maybe I set it up so that you can access the data of the circle, but you can never modify it. And that's exactly what I just did here. And that will propagate through. This is, so this will break on me everywhere I do a set, because there is no member. Oh, wait, I just commented it out. Oh, I didn't mean to comment it out. I can make it, yeah, I can. There's no set function. I was thinking you can make it private as well if you want to make it so that Circle can use it, but nobody else outside of Circle can. Two different ways to get me there. Okay, so, but if I comment out, there's no way for me to modify the X value while the program is running. Perfectly legitimate. Both ways are perfectly legitimate. Okay, so one last thing here. Let's see, before we get to, oh my goodness, how many of these things? Just a couple more details. Continue more details here. Again, there's two different ways we could do this. My way is to separate, this is the best practices way again, is to separate the circle.h from the circle.cpp file. And it comes down to, again, security and things like that, and just having your API, having your interface available. And if I give you this interface and I give you my code, I've given you my hard work. A lot of the hard work is paying my engineers to create all the code, to engineer the product, to put the whole thing together. And if I just give you all the source code, you could just reverse engineer it or do whatever you want, and now you don't have to pay me a darn thing. I could sue you, but that takes years and all sorts of crazy nonsense. So that is part of the reason why the .cpp files are completely separate whenever possible from the .h files. And so that's, and then we use the include file in the CPP to get me into the H file. So that's the major reason, is just to keep your code simple, right? First off, all the details are kind of eliminated from, the declaration of what is available to me. And then also, again, that my code is kept secret. So if you want it, you'll have to pay for it. But because I can compile this thing down and give you access to the API, but I'm not going to give you source code unless it's open source or you pay me for it. Okay, so let's just pretend, let's say you can pretend that the keyword inline doesn't matter. Let's see, how much more do we have to go? Okay, finally, just last thing before we can get on to the idea of a constructor. So you can have this thing called inline. And so this is always kind of a tricky thing. So just after I'm done explaining it, you can look it up using a different method if you want. But you can declare inline, and usually when you do this, the compiler will set it up for you. I'm surprised it didn't do it already. But what happens is, just knowing how a compiler sets everything up, what happens is, whenever I call a function in a programming language, I have to push information onto a call stack. I have to put a memory address for where to return to when the function ends, because it has to know where to return back to. A lot of times I'll pass in parameters for the the inputs, and then and then I can finally call my function. The function does all of its work, and then it has to pop all that information off, return something back, and it's a lot of work that has to go into just calling one function. And so if it's a lot of things to do to make this thing work, sometimes it's easier just to kind of forgo that and when we call things inline, we don't call a function, we make the function just basically come to us. And so instead of making this thing 5 or 6 lines of code, or pushes and pops and all sorts of things that go on under the hood, you basically take the one line of code and you jam it in as if we're doing it like a struct, basically back in the day, like just pretend it was public information and just jam it in. And so it speeds everything up, but it only works for very small functions, because it can only, if there's any function that, basically the larger the function, the less it's worth us to do, for us to do that, because a small function can get a very large return. Instead of doing 5 lines of code, I could do it in 1. But once I start going more and more code, it's less and less worth it. And on the other hand, also, when I do it this way, my code gets larger, because instead of having my function put here one time and I use that function over and over and over again, the truth and the reality is I take that function and I pop it in everywhere. So even for small functions, if I'm using this 1,000 times, I have the code for that function popped in 1,000 times instead of 1. So it's this is one of those things where it's a trade-off between size and speed. If you have plenty of size, throw an inline. It can't hurt you. But if you have space constraints, you probably shouldn't do things this way, and maybe have to try to find a different way to make your program a little faster. So that's what inline is all about. There's no reason for us to tinker with it here, but just so you know it exists, because it's my duty to teach you since it's in the book. All right, so let's take a look at constructors, the idea of actually setting up an object and actually setting it up so that I don't have to do things with my source, so that I can, in the line of code here where I set up C, I can do something like this. I can go and set up these values like you see, which the compiler will throw me a problem because there's no such thing. What does it say? No instance of constructor matches the argument list. So let's discuss the idea of what a constructor is. So a total of 2 things are wrong here when it comes to, not necessarily wrong, but just not best practices when it comes to setting up this circle object using set, set, set. And so one of them is, this is a pretty simple object type, and so maybe it's not that big a deal to do c.set, c.set, c.set. But what if this thing was like a video game object, and every video game object has 50 different attributes, because there's a lot of stuff going on inside of a video game character. And should I have to, as the person using this, remember all of those details, all 50 details to get this thing to work instead of 50 lines of code, set, 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 set? No, that is not true. And another thing that can happen is, what if I forget, like I said, if I forget any one of them, or things changed under the hood somewhere, and it's like, oh good, or just, you change the specs and something, and you forget to go back to one of those objects, and then, oh my goodness, you just add one thing to every object, and then you have to go back and do it for every object in your entire game or your entire project. It's a big, big, big pain in the ass. So that is, so that is the main reason why this isn't going to work. Because if things change, things break down. So this idea of a constructor would be great. So I don't have to remember every detail. This idea of a constructor, the function that will do the work of setting up everything, all the variables, the member variables under the hood, it will do all the work for me, but it will just ask me for the things that are most vitally important. And so and this doesn't exist yet, so I can't show you the IntelliSense, but you could imagine this would be the X value, this would be the Y value, and this would be the radius, just like we had before. And so now it would all be placed into one line of code. And we would be very happy with this, because then the user could put this information in and they know what is expected of them, and the IntelliSense will actually assist them in figuring out what to do, as opposed to having to remember all these details for the circle class. Okay, so again, a constructor is an automatically called, so then once we set this up, this is basically calling this constructor idea to set everything up. And its purpose, of course, is to construct the object. And the name, this is one of those weird things. It doesn't have a return type. The function is the same name as the class type. And so it's one of those things. It's a weird kind of thing. Let's see, do they show them here? So they're going to show it here. Rectangle with parentheses, that's the default constructor. And so just to say that there's a difference between a default and a non-default constructor. So let's just go ahead and let's just do it the right way here. Let's just set up ours the correct way. And so to set things up, let me find my circle.h. So what I would want to do here is have my constructor object called circle. Called circle, there we go. And so what would I want to pass in? I would want to pass in the X value. I would want to pass in the Y value. I would want to pass in the radius. That is what the function should look like. Right now, I'm not talking about the implementation of it, but I'm talking about how that function should look from the syntax level from over here. And so now, yeah, this isn't working. Why isn't it? Oh, don't mind that so much. Let me just get rid of the D stuff here. So you go, okay, circle C, 0, 2, 3. And so now at least it compiles. It won't link because I didn't include the actual definition of the function just yet. But you can see that we're a little bit closer. And that's what is going on right here. Oops, right there. Okay, so here's their rectangle class with their rectangle, and then it's defined here as a rectangle with no width and no length. So I might as well go ahead and just show you. It doesn't make any sense in this context. If I'm going to force you to create an XY position and a radius, why should I allow you to just set up a blank empty one with no position or origin position with no radius? To me, it doesn't make any sense. But just to show you, I can go ahead and I can have two constructors that take different parameters because I can overload the constructors. So we've done this before. You mouse over the whole thing, you right click, and then you can set everything up, and there's everything up here. And so now setting everything up. They do things this way. Let's use what's called an initializer list. Why not show you best practices? So what happens here, just your contract as the developer of this circle class, the developer of this function called, the constructor function, is when you close off and hit that closing curly brace inside of a constructor, you are guaranteeing that every parameter, every member variable sitting under the hood for that object is initialized to something that isn't just random uninitialized garbage. That is your contract. So in this case, there's the width and the length. They did their job. They didn't do it 100% correct because they're not using an initializer list, but they did do the job of getting 0 set up for the everything that's sitting under the hood when it comes to variables. And so for our case then, we would do the same thing. It's just a little different here. And I would say x, I would say 0.0, and I would say, oops, and I would say y gets 0.0, and I would say radius gets 0.0. And again, I'm only doing this to show you. I do not believe that this should be part of this class. And I usually put like an intentionally left blank kind of thing, just so that someone looking at my code later goes that I know that I left this blank. Because if you see blank stuff, you might wonder what's going on under the hood. Did this guy know what he was doing when he was writing this code? So x position is 0, y position is 0, radius is 0, and I can do it. I can get away with it. And so the only other thing here is to do the same kind of deal here and say, okay, I'm going to set up x with the capital X. I'm going to set up y with capital Y, and I'm going to set up radius with capital radius. And then put the nothing here again, just so that everyone knows what's going on. So now, again, x, y, and radius are my 3 private member variables. And so when this closing curly brace gets hit, in both cases, x, y, and radius are set to something that's valid. Even though 0, 0, 0, it is valid, it just doesn't make much sense. Okay, so coming back here. All right, so they have all this, and notice for their set functions now, they kind of added a little bit more. They added a sanity check to this. Oh my goodness, what happens if you try to set the width to a negative value? It just stops the whole program. It just goes nope, and exits the program with a failure. So we're not doing anything like that, but there could be reasons for that kind of thing. Throw an exception. If something goes wrong, like credit card transactions or whatnot, what should you do? Should you just throw up your hands and just say, okay, nobody has to pay tonight because we had a machine malfunction, right? The bank would not be happy with you if you were developing software like that. So, and again, what happens when errors occur is completely dependent on the company or just the situation at hand. So we don't have anything like that, but the constructor is now working, and we can try it out, and now my line of code works here. This will work now. So there we go. I go in F11. Up it goes over to here. So come on, help me out. Not doing it. There we go. So you can see the arrows over here now, and you go, okay, and then it goes up. Whatever goes on the initializer list occurs before anything you put inside of the block of code here. So it would actually, it's initializing pi, and now it's setting up x, y, and z. So x is currently garbage, but now it's 0. Y is now 2. Radius is now 3, and I'm out, and my circle is set up appropriately. pi 0, 2, 3. Everything is set up appropriately, and now everything works exactly like it's supposed to before. And I don't have, and I could set this up if I wanted to, but now that I have this, I can do new circle now that I have a default constructor. So I can show you the second way, the way the thing goes now. Whoops, let me just set it up. Let me try again. So now I can go in, and this will go into the default constructor over here because I'm not supplying any parameters. This is the default version of the constructor that I'm using as opposed to the one that was more of a custom one a second ago. So this one will set up pi 0, 0, 0 for everything. And so D is now set up to be, oops, one more line here. Boop. D is now set up to be 0, 0, 0. I can set the radius version here, go in and change it to 4, and now D has 0, 0, 4 for those 3 parameters, and C still has 0, 2, 3 for those parameters. So that's what a constructor is all about. You're never going to get a compiler warning or error if you only initialize half of the things inside of here or none of them. It's presumed you know what you're doing. This is my warning to you that you know what you're doing, and you have to set up every variable to something valid, or at least just something that's non-garbage before you start. That is your contract to the end user using your code. So again, we discussed this. The default constructor is the one that takes no parameters. There can be a default. It's called the default because we used it earlier, even though it didn't truly exist. If you don't create a constructor, there's a default one that gets put in place for you that just gets everything going. It doesn't initialize anything because we showed that in a previous 20 minutes ago or however long ago. But the thing is that even though there's a default constructor, the second I create something that's more custom, the default, there's no longer a default, because default, it means default, something to fall back on. But once I create this circle constructor with more custom behavior, now it won't let me do this, or I'm saying, let me kill this code just for a brief second. Now, with this gone, with this thing not part of my program, it says there's no appropriate default constructor available, even though there was a minute ago before I created this version of it. So just so you're aware that it's default for a reason. Okay, so we've already talked about passing arguments to constructors. We've passed 0 and we've passed 3. So and this one uses 2 because you need the length, the width and the length. However, you got to watch out for that. If it matters, the width and length matters to you, you got to make sure you do the right one correctly, width and length and width, depth and whatever. So you got to watch out. We passed parameters. We passed 3 along. And what's cool about this is we can actually set aside, so we can kind of combine both of these into one constructor. And so the idea here is about default constructors and default parameters to constructors. And so what I can do over here is say equals 0.0, and I can put equals 0.0, and I can put equals 0.0, and I can get rid of this. And then now I legitimately can get rid of this now. And so now what happens is, if I do not supply the specific parameters, whatever value I have in here gets filled in by default for me automatically. So now I only have the one constructor, and you only put the values in the .h file. You don't put them in the .cpp file. So notice equals 0 goes here, equals 0 does not go there. And so notice here, both of these now work. These both compile down and work just perfectly fine. No warnings, no errors. That warning isn't even part of, this is just because I've been using this I've been ruining this thing a million times over with different classes and stuff like that. But now the one constructor works for both cases. And so the zeros get filled in for me when I set things up for the D pointer, but I use the parameters that I supply whenever I supply them. So I'm exactly the same place I was before, where the first time through it'll supply 0, 2, 3. The next time through it'll supply 0, 0, 0. But one of the side effects of this is that now I have a 0 parameter version, I have a 3 parameter version, and I actually also have a 1 parameter version and a 2 parameter version that I didn't have previous. So now because what happens is once I stop with the parameters in the list, then it just keeps on going adding zeros. So I now can have, these are two of them, I can have 4 different versions of a constructor now. Right, so now I can say this is the 0 parameter version that fills in zeros for everything. Maybe let me just change this up so 0. If I'm already filling in zeros, how do you know what's working, right? So what happens is everything gets filled in with zeros for the circle, and for this one is presumed to be the x, and everything else will be filled in with zeros. This is the x and the y, and so the radius will be filled in with zeros. And then the 1, 2, and 3, this is the only one where nothing will be filled in with 0 because I've supplied a variable, a value for every member variable under the hood there. Okay, so that's a big deal there. So now it's pretty cool though, because you don't have to write 4 different constructors for the same stuff. Okay, so we'll discuss this idea of a destructor later on, much later on in the course. Not much later on, we're getting closer to that much later on. But if there's the idea of a constructor, there is the idea of a destructor. And so, and we're not, we don't necessarily need one right here for the circle class, but we will later on when we get to creating our own custom data types. So what you do is, to create a destructor, what do I do when my object is being destroyed? When it's going out of scope, when it, that kind of thing. And so it gets the tilde. So it's automatically called when an object is destroyed, which is nice. It gets the tilde. It has the same rules, no return type, no parameters passed. It should always be public. And so the last line is basically why we would need this. If we're going to dynamically allocate memory inside of the circle class, this is our opportunity to release it. And so again, for now, if you don't 100% get what that means, just give it a couple weeks when we get to and showing you how that works out under the hood. But basically, if I new up memory, if there's like a whole collection of data sitting under the hood, and I want to make sure there's no memory leak, and I have pointers and newed up memory, this is my opportunity to go back in and delete everything you see. And so again, I don't have to do it for this class, because I don't have any dynamic memory, so everything is handled perfectly well for me. Did I do it? I thought I did it. Let's see, what did I do? Don't know what happened. So technically speaking, I can just fill in and just say nothing here, because there's really nothing to do. I'm not, by putting this in and putting nothing here, I'm not losing any behavior because it really wasn't doing anything anyway. It's a default destructor that is just kind of there because it needs to be there for the program to destroy this object. But it's not doing anything, because even though there's an X, a Y, and a Z, or a radius, you don't have to worry about destroying that because the stack will unwind that perfectly fine for us. It's only when we new up memory and we're not using the stack, we're using the heap, that's when we have to basically ask the operating system or tell the operating system, we're done, this object's being destroyed, you can have this memory back. Because if you destroy the object and don't destroy the memory, there's no way for the object, that memory for the operating system to get that memory back. And you let your program run long enough, your program will halt because you're losing all that memory and you're never giving it back. Okay, so delete, delete, delete. And so when do you see this destructor get called? So obviously the constructor gets called any moment that these things come into existence with the line of code 6, 7, 8, 9 here. But coming back to it, how many, if I just put these things, and you can do this, put these things inside of here, and let me move this inside of here as well. And so you're like, okay, 4 circles get created. Well, how many times do these things get deleted, right? So let's, how do when these things go out of scope? So let's find out. Uh-oh. What am I doing? Oh, let me put everything inside the closing curly braces here, just so I feel better about it. Okay, so I build, what now? Oh, multiple definitions of A. Okay, we'll put a B. Hey, have I been sitting in front of the code the whole time? I'm sorry, guys, if I have been, I'll move myself over here. Okay. My apologies if it's an hour of trying to figure out what the hell I'm doing. Sorry about that. Okay, so, but what am I going to do? I'm going to hit this line of code here to finish everything off. And so 4 constructors have been called of the different types, and What happened? Okay, what's wrong with my code? What's wrong? Oh, there we go. I don't understand, but that's okay. But now let's see what happens. I go in F11. I get the circumference. Here, let me make this big. I get the circumference. I do the work. I go back. I print out, and I hit this closing curly brace, and now there's the destructor. And it's, can we see which one? I guess not. Maybe we can. Let's see. The one that's 1 and 0 and 0, which is the B. The B is being destroyed right now. I guess that's the the closest one, on the top one on the stack. So then, okay, I can come back along and do it. And when I do it again now, what am I doing now? Because it's closing curly brace. It's destroying another one. It's destroying the one with 1, 2, 0. So it's destroying the A one. Okay, fair enough. And let's do it again. Go in one more time. See this. Now go F10 again. And now I'm destroying the one that's 1, 2, 3. And now I'm going back. And now that's it. That's done. And you're like, but I did 4. And that's exactly what I was talking to you about scoping rules. Like, I didn't give back that memory. If I knew something up, I have to tell the program I'm done with it. I have to delete it myself. And so to get that 4th delete, I have to go down here, the 4th destructor. I have to go ahead and say delete D. And if I put it here, it'll work. If I put it down here, it won't work because D goes away, and I'll have that memory leak, and I'll have a compiler error as well. So you just have to watch out. And now let me just put a breakpoint in here, just so you can see. I'll hit this 4 times now. 1, I hit F5, 2, 3, 4, and then I hit F5, and the program will complete. And there you go, because it hit the destructor 4 times to destroy each of the 4 items. And which one? Now the question is, which one goes first? Probably D went first. Let's just see. Now we can see the one that's 0, 0, 4. So this one is on the stack. D got deleted first because I'm explicitly deleting it here, and then the other 3 get deleted when I hit the closing curly brace. So this is a huge deal when it comes to memory leaks and dynamically allocating memory. And so again, we'll see this for vector and set and anything you'll be doing out in the world where you're dynamically creating data structures that are a little more complicated than just simple things that are just storing data. You will see this, at least in C++ you will. Maybe not so much in other languages, but you'll be using references. You're doing the same deal. It's just the syntax of it is a lot nicer nowadays as it was when C++ came around and just did the things it did. Okay, so let's see. Boom, move this over. Okay, so we have already discussed the idea of overloading constructors. So we've already overloaded them so that we can have 4 separate constructors, but we kind of showed the process of starting with 2 separate constructors and then creating one catch-all for all 4 types. So you can see you can have the 0 parameter, 1 parameter, 2 parameter. They don't even have to be even similar to one another. You'll see when we start discussing vectors and all that the constructors can have completely different parameters, iterators versus integer values versus this versus that when it comes to initializer lists and things like that when it comes to what I can put in. And as long as it's a different list of parameters, you can have as many as you need. So they're going through their description just like we went through ours. And so again, okay, so the one thing we didn't discuss is this idea of constructor delegation, and it's kind of come along in the newer standard. And so we'll show this again in the future, but just to understand that even if you have 2 constructors, that you generally only want to initialize the actual data in one of the 2. I don't want to have 2 copies where X's and Y's are set up and radius is set up. And the reason for this, again, is because if I go back and I modify this thing over time, like over the 2 years of my project, if I have 5 or 6 different constructors and they're all similar but not the same, but they all end up getting me to the same place. If I add a 6th one or whatever, I need to change things over time. And I forget, and then you always say, I'll never forget. You sound like my 5-year-old here. We're just talking about, I'll remember to do. They never remembers to do that. And so, like, you're doing a million things over the course of a day, over the course of a week, a month, the whole life of your project. You're going to forget little details like that. You're going to have subtle bugs that are going to take you half a day to find somewhere a year down the line. And so if you can only initialize the data in one place and have all the other constructors call the other constructors, and call, from a constructor, call the other one that does the real work, sort of like an initialization function. That's how we used to do it before the 2011 standard came out. That is the way to go. And do they show it to you nicely here? So this is kind of how things would go. You would have two constructors. You would have the default one, which would call the more custom one. And so notice these are strings for name, email, and for phone, for whatever reason. So the default constructor that takes no parameters would, inside of it, would call the other constructor here that would actually set up and set null strings for all of them. Notice null string or empty string, empty string, empty string for N, E, and P. And that's how you would go about doing it, instead of setting up and saying name equals quotes, email equals quotes, phone equals quotes, and have the same things going on in two different places. Just so you are aware that it exists. And there are other little details that we don't want to talk about right now. But also, if I can overload a member function that's a constructor, I can overload anything else. It's just the same way. As long as the function signature has different parameter types, if I had set cost, I could pass in care pointers. I could pass in double. Of course, what that means is completely dependent on what your program is trying to do. But it's the parameter list itself that has to be unique, because you can't change the return type. You can't change the name of the function. You can't change the constantness of it. The only thing you can change are the parameters stored within, and they have to be completely, distinctly different for something like that to work. All right, so the one last thing, we're getting closer to the end here, private member functions. So say like, why would we ever need stuff like that? And we will see later on what these are basically like helper functions, things that I don't want an end user to be able to access. So when we get to recursion and things like that, like there are things that I want my program, and I want when I'm doing an algorithm, I need these helper functions, but I do not want someone to go in and just use them for just no reason, just because they can. And so I can, by making it private, just like we saw earlier, the outside world can't use the thing, but I can use it in the process of doing the inside work. Basically just think of how your heart is pumping, right? That's private data, right? How fast your heart rate is, all of those kind of things. Like it is private, and it's doing its job, and we're not, the outside world doesn't think about it, but it is doing everything it needs to do. So it's a private thing. Boom, 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 boom. All that kind of stuff. Been a long time since I remembered all that stuff. So a private member function can only be called by another member function. Fair enough, right? So it cannot be called by the outside world. So it's used for internal processing and not for use in the outside world. So that's basically the end all be all of it. Okay, so let's see. How much more do we have to go before we got to get to the other stuff here? Okay, arrays of objects. Vectors of objects. We're going to be moving toward having vectors of pointers and all sorts of crazy stuff. That's we need these pointers so that we can do inheritance and polymorphism and so forth. So you can say I can set up, just like we can set up an array of structures, I can set up an array of objects. So I guess I can get rid of, well, no, I guess keep it all for now. So I can say give me a circle, I'll call it array, and I will say give me 10 elements. And so what will happen here is array will call the default constructor for all 10, or will it? Let's find out. Array, 10 items, and they are all initialized. Isn't that weird, right? They're all actually initialized, even though, whatever. It calls the default constructor, and the default, if I didn't have a default constructor, or if I didn't have the constructor the way it was, it would actually set it up with garbage data. But because of the way this is set up, it calls the default constructor, which is defined by me as setting everything up with zeros. So in our case here, the circle array has 10 elements, and they're all accessible through, or they all have 0 values, and they're all accessible through, saying something like this, right? So I'm running the program, that's why it's not showing me. Oh, I'm not using pointers. I'm using an array, just plain old array of not pointers. So I'm used to using pointers, sorry about that. So I can say, get me the 0th element of array, and then get me the x value. Double R equals. So again, it's just one extra level of indirection. Why is this a problem? Hold on one second. Expression must have pointer type. Thought I did it. This is the fun of this. Getting something to work like this sometimes. What was wrong with, oh, whatever. IntelliSense is a lot of fun in C++ sometimes when you're fixing mistakes you really didn't even have in the first place. So this is saying, okay, array is an array of circles, and array 0 says, okay, go from an array of circles to a circle, and then the dot operator here says, okay, go from a circle to the double, which represents the x attribute, and then take that value and put it into R. So that's how things are working. And so it's, again, just another level of indirection, and just it takes a while, right? And because I'm not using a circle pointer, I don't use the arrow operator. I only use arrow when I'm doing something where I have a pointer and I need to dereference the pointer and then do some operation on the dereferenced pointer. So that's why I got a little thrown off there. I'm just used to using pointers a lot in my life here. And so in this case, circle is just a plain old circle object. It gets the dot operator like structs and everything else that we've been using. And so I'm not going to worry about it. You can initialize all 10 of them individually, however you see fit, but it's not important. But you can kind of see their example, setting up 3 objects using different parameter lists and stuff like that to set up the thing, hard code this list. But it's not necessary to worry about. And accessing objects, as I was saying here, for gets and sets and everything else, just logically think out and talk out what you're trying to do. I need to get the x value of the first element. So I have to go from, and one more time, I'm just repeating this again. I need to go from an array of circles down to a circle, down to the double that represents the x. So it's you can always work your way, use your finger and kind of think of it, bounce around like an arrow, and just go from array to circle to double. And that's what I've got now. And wow, they're going crazy on this initialization stuff. Don't know why we need so many slides for that. Okay, so the last concept here is the idea of unified modeling language, UML. And so I took a whole course in this in grad school, and it's not like it was the most challenging thing in the world. But when you're architecting a system, as much as it's fun to write code, as we're doing, if you spend a little bit of time up front and you think things out, your program is generally going to go a lot smoother than if you just hack away and then at the end you go, oh man, I didn't think of this last little detail, and then you got to go back and fix everything up. And that's generally programming in a nutshell. That's why programmers, there's jokes about that. It's like, why isn't he doing anything? It's like, I'm doing a lot inside of this crazy noggin of mine. So I'm trying to figure out how to get things together before I spend the time, because if I could solve my problems before I even start, there's going to be no work to do on the back end. But if I wait until the entire project is done, find that mistake, how much work is it going to take to figure out how to get everything working, especially if it's a huge system and it's a fundamental flaw with the entire algorithm or whatever? That's a big problem. In our case here, it's like the cart before the horse. We've already done all of the work. And so basically the unified, is just a way of basically making this a little more human readable, because the UML diagram is more agnostic. So if I write this out using a UML diagram, I could theoretically take this diagram and put it into any language, because it's an understanding that it's pseudocode. It's basically a template for what I really want to accomplish in whatever language I'm going to be moving on into. So there's more to the UML than just this. There's 7, 10, 12, I forget exactly how many different modeling systems that apply, and for completely different topics and different ways of doing things, interactions of objects and all sorts of crazy things. So as you see here, let me just, well, I guess, let me, to make this work here, let me take this, copy it, and give me 1 second. Okay, so I basically copied the .h file into an Excel worksheet. And so what we're going to do is basically, again, we've done the work before we've done the setup, which is the opposite of how you would do things in real life generally. So let's just take a look here. There's 3 separate sections that go into this. There's one box that goes ahead, and that's where the class name goes. So we'll just call this is circle. There you go, you're 1/3 done. And so the next portion is where the member variables go. And then after that is where the member functions go. So there's 3 parts to this. And so what we do, and I'm just doing this here the best I can. Let's see, I'll make that a little bigger. There we go. And so these sections fill in with all of this, and let's just take a look at what they did here. So they just to get going here, we have x, y, and radius. And so then we also have, oh my goodness, right? And I guess technically we have pi, because we haven't introduced the keyword static yet, so I kind of left it alone. That's why it pops up everywhere it goes. It's not. We'll talk about static in the next video. I think it's the start of chapter 14. And so I've set up this, and you can see here, I'm just going to go ahead and do it the right way because I'm just converting it over as it is right now. So x is a double. Notice this is different syntax than what you're used to seeing in C++, because this is UML syntax. And so this is x is a double, y is a double, radius is a double, and then what I also do is I put, because all 3 of these attributes, all these are member variables, are private, I put a minus in front. Whoops. And now I just have to set this so that it's formatted as text, because I should have done this in Word maybe, I don't know. Let's see, equals, get rid of that. And so the minus key, the minus indicates private. So this is a private variable called x, which is a double. A private variable, which is called y, which is a double. A private variable, which is called radius, which is a double. And so the remainder of all of this would be the functions. And just getting things going here. So this is just to kind of get started here and move everything over. And now we can kind of get rid of this, because all we care about at the end of the day is this guy right here. Okay, so getting closer here. So now adding to this, okay, we already did the pluses and the minuses, at least for this. We'll fill it in when we get here, because they'll all be pluses, because everything we did here was public. And essentially we're just setting up, we're basically setting the header, we're setting up the interface, because a lot of times you don't have to implement things, especially if you're architecting and engineering, like you know what it's supposed to do at a high level, and I'm just trying to figure out a high level understanding of how to interact these objects, these complicated systems together. Later on we can, someone can just do the boring work of just making some of these really boring functions work. So, okay, so you see that, and then we just go ahead, and it's a little different here. So like with this, the circle, okay, takes in x, which is a double. You could fast forward this for sure, if you haven't already. Y is a double. And I'm just getting rid of the, I guess, I don't know if you should leave in the, default parameters or not. It's been a few years since I've gone into the actual details, because a lot of times you do these things, you do them your way, and you don't do them the true UML way, and then it just ends up like this. So I'm going to delete this one. Where's delete? Delete, shipped up. So circle destructor doesn't take anything, So now these guys, right? So delete this. This is just where things get a little more complicated, because I have to include parameters and return types. And so C++ is kind of one of those, it's kind of weird, I guess, in that it has the return type up front. So I just have to take this and just say, okay, get x, don't worry about the constants, I suppose, and just say it returns a double. Oops, oh no, put it back, no! I have to do it over again, because I hit escape when I wasn't supposed to. So get x is the function, I'll leave the constant this time, it returns a double. And it is public, so it gets, all of these get a plus. Uh-oh. Yeah. Oh. You get the purpose here. Maybe instead of putting it here, maybe I put them here in their own column. Oops. Excel is they are trying to help me, right? So there we go. I could feel a little better about it. There you go. So I don't have to put them in here. You just know. Okay, so get x is a get x const double. This is a set x, and this actually takes x as a double, returns void. X is a double, and then it actually goes at the end here, returns void. Oh God, I did it again. Brad know what he's doing? Sometimes. Sometimes Brad knows what he's doing. I can get rid of these semicolons as well. And so there's my X, and now I can just copy paste these a couple times over so that I could just deal with the Y's. There we go. I'm thinking smarter, not harder here, right? So, and then radius. But you get the gist, right? I mean, there's nothing. Again, because I've already done the hard work, this seems pointless. But when you're doing anything that's larger than just a tiny problem, you can understand where this is coming from. And so let's see, no, make this good all around. Okay, one more here. Double return type. Double, and then one more return type double. And there I go. I can eliminate all these. Delete all this and bring it up. And there, and then close this thing off, and I have my UML for this class. And so yeah, so just notice, yep, I'm doing everything correctly, slowly, no doubt, slowly, but I'm doing everything like I'm supposed to do. Did I miss anything here? X, Y, everything colon double, colon double, colon double, colon double. The word double is looking really weird now because I'm staring at it. It looks like doobie. Anyway, so doobie. Anyway, coming back. So then here is something for inventory item. It's the last slide. Something that's a little more complicated than what we have. I guess they put their constructor into this, which has no return type. Again, there are rules, but they're not hard and fast rules, at least according to me. I would never force you. I would never be one of those people that says you have to do things exactly this way, because I've been in so many different companies in so many different situations. It's basically kind of a half shorthand way of doing things, because the whole goal is to make your life simpler. So that all the other functions are public. Everything there is private. Everything here is public. And you can see with pointers and all sorts of stuff and voids and care pointers that we have ourselves the deal here. And so now, as a junior developer for a large company, the architect would hand you these kind of things with details, and it would be up to you to actually write the hard-coded stuff and start testing all of this and start putting it together and start reporting back and doing the work of actually architecting the system, because that's why there's a difference between a programmer and an architect. Sometimes they're the same person, sometimes they're not. Depends on a lot of factors, and if you're working for a company, not for yourself, it's generally not your call about how you're going to be doing your work. So that's how things go. So that is chapter 13 in a nutshell. Don't know how long this video has been. It's got to have been at least an hour. And so very important stuff here, because now next chapter 14, we're going to look into doing more with objects. We're going to add copy constructors and operator overloads and all sorts of things that we need to include in this to make this more powerful. So then when we get to chapter 15, 2 videos from now, we can go nuts and include inheritance polymorphism and show you the true reason why we're doing all this hard work, setting all of this up, using pointers and all of this stuff to make it all come together in the end. So swardb@cod.edu is my email address. Send me a comment there. Send me a comment here on YouTube. I'll get back to you as soon as I can. Thanks for sticking it out with me. We'll see you next time.